here hydrogen. Right. So here this particular. Okay. So with enol, this is en and ol. Okay. So this is the carbonyl here. So carbonyl ketone, where this keto group is undergoing the enol tautomerization. You know that keto enol tautomerization. Okay. So where this particular enol form to this enol form, you can add the different reagents like ammonium carbonate upon heating with ammonium carbonate. So you get this pyrrole and same thing by heating with by adding the phosphorus pentoxide P2. Okay, by heating with P2O5, so you will get the furan. By treating with the phosphorus trisulfide. Okay, P2S5. So heating, so it is going to form the thiophene. So very simple synthesis, right? Very simple methods applied to synthesize these particular three heterocyclic compounds. So this is the polar synthesis where we are applying to synthesize the three heterocyclic compounds like pyrrole, furan, thiophene. And one more synthesis of pyrrole, very simple, where acetylene, right? So by passing ammonia in the acetylene gas, okay. So hard group, acetylene hard group. So red hot group here. So we get the pyrrole. And one more method is right, so by distillation of succinamide or zinc dust. Okay, so zinc dust. You will get the pyrrole, substituted pyrrole here. Okay, hydroxy pyrrole is going to form. Right? Then zinc dust. Okay, so generally zinc dust, it is a dehydrating agent. Okay, so upon reacting with the zinc dust, you get the pyrrole product. And one more method which is employed to synthesize this particular pyrrole is here. So when this glycerol, right, is means the yeah, so amide derivative, right? So here the amide derivative is reacting with the glycerol and ammonia. So then simply the decarboxylation followed by the dehydration. Okay, 2 moles of carbon dioxide and 2 moles of water is going to eliminated from this particular right, amide derivative here, and it is going to form your right, furans, pyrrole, sorry, not furan, pyrrole. And furan synthesis is taken up by using polymer synthesis is one of the method, and by taking furan, you will get the pyrrole. Okay, right? So by taking furan, here we are taking the furan here. So when this furan is treating with the ammonia and aluminum trichloride, so aluminum trichloride, we call it is alumina, right? So aluminum trichloride, which is alumina, but you need to apply higher temperatures, right? So 400 degrees Celsius. So for generally, you know that for the to imply or to apply the higher temperatures, you need to use a silicone oil or you can furnaces more. Okay, so more temperatures. So oil bath, you take the silicone oil. So by with silicone oil, so you will get the temperature over 300, 400 like that. Okay, so up to 100, you can use a water bath here. And if it is more than 100, like up to 200, so you can use a sand bath, right? And sometimes you use a oil bath also. But silicon in the silicon oil, you can raise the temperature up 300 and 400 here. Okay, so when the furan is taken, furan is heated at 400 degrees Celsius with ammonia and aluminum. So you get this particular furan. Now the furan synthesis. So for this furan synthesis, where the pentose sugar is taken, right? So this pentose sugar, uh, when it is undergoing the treating with diluted sulfuric acid. Generally, here the sulfuric acid is a dehydrating agent here, right? So this pentose sugar, it is converting into like tetrahydroxycarbonyl compound, and this tetrahydroxycarbonyl compound, upon heating with the 3 moles of by removal of 3 moles of water, so it is going to form the pure porphyra, right? We called it is a porphyra like that. See, okay, so this is porphyra here. The furan where it is aldehyde group is attached to this furan, this porphyra. So this porphyral further treating with the calcium oxide, right? Calcium oxide, calcium oxide. Hmm? మేడం చెప్తారేమో కానీ ఇంకా చెప్పలేదు కానీ చెప్పండి. So calcium oxide at 350 degrees upon nickel steam. So furan is going to form. Right. So with common method to synthesis, right? The common method to synthesis this particular these three is a Palna synthesis, very common method for synthesis of the heterocyclic compounds, furan, pyron, and titanium. And one more method we are going to apply to synthesize furan is so where here is a mucic acid, okay, upon distillation. Okay. So same as the above method, right? So in the above method, generally we are taking the right so pentose sugar. We are treating with the diluted sulfuric acid here. Okay. Now here we are taking the mucic acid, and when it is doing the distillation here, right? So distillation we have fractional distillation, solvent distillation here. Okay. So upon distillation, where the by 3 mole of 3 moles of water and 3 moles of carbon dioxide, where it is going to form the furan 2 carboxylic acid. Okay, furan 2 carboxylic acid. As you can see, it is 2 furanoic acid. And this furan 2 carboxylic acid further decarboxylation upon heating. Right? So upon heating, by decarboxylation, it is going to form the furan. Right? So like this, you can synthesize this furan. Now we are going to synthesis synthetic methods of the thiophene. Right. So as I told you at the very beginning, like the synthesis are very important in the exam point of view. Now here the thiophene synthesis is done by taking the coal tar benzene fractions here. Right. So when this coal tar benzene fraction, when it is heated with the uh, yeah, carbonate, mercury carbonate, so it is going to mercurous thiophene derivative. Then upon simple uh, reacting with HCl, washing with the mineral acids, HCl here. So with the pure thiophene is going to form. And one more method is to preparation of the thiophene is. So very simple method where we are by taking the butane, N-butane here. When it is treated with the nascent sulfur, okay, nascent sulfur at 600 degrees Celsius temperature, higher temperature. Okay, so where this 3 moles of H2S, H2S gas, by evaluation of the 3 moles of H2S gas, the thiophene is going to form. Right? So, and acetylene gas also when it is treated with the H2S gas here, uh, by treating with aluminum, uh, alumina, Al2O3. And the last method to synthesis this thiophene, right? So here the sodium salt of the carboxylic acids, okay, disodium carboxylic acid here, when it is treated with the phosphorus, okay, pentasulfide, P2S5, right? Overheating, so it is going to form the thiophene. And you see, if you see the physical properties of these, right, the heterocyclic compounds like pyrrole, furan, thiophene. So when you check the molecular weight of these compounds, pyrrole it is 67, furan is 68, thiophene 84, benzene is 78. You know that how to calculate the molecular weight, right? So generally here the molecular weight means the atomic weight, right? So the total atomic weight of this. For example, if you take benzene, right? So benzene is right. So molecular formula is C6H6, isn't it? So here the C generally carbon atomic weight is 12. 12 into 6, it is 72 and 6 hydrogens. Okay. So total 78. Okay. So it is 70. So likewise, you can calculate the atomic weight, molecular weight of the pyrrole. Right. So here the pyrrole is right. So where the 5 member, where the number of carbons, how many it is here? 1, 2, 3, 4. So C4, uh, H, how many hydrogens? 1, 2, 3, 4, here 5. C5N, C4H5N. So carbon it is 12, right? So 12 into 4. How much it is? 48 and 5 hydrogens here. So it is 53. 53 plus nitrogen is 14. Is 67, right? So like furan also, how much it is like here the in the pyrrole and furan, the difference is the heteroatom only, isn't it? The number same C4, H5. There is a H4 only because in the pyrrole there is a NH group. Okay, but in the furan there is no NH, so it is oxygen. Class, online class. So it should be subscript, not superscript. HF hydrogen, it should be subscript, below ion, down.